Welcome, we're going to take the first steps to programming our AI to play Atari's Breakout. The point of this game is to move the pedal around in order to keep the ball in the upper part of the screen and to destroy as many bricks as you can. We call the AI the model. The model chooses the action which is input into the game environment, which is represented by the game console in this picture. And this environment calculates how the game reacts to the action. And it serves it as an observation back to the model. And this observation is what we see on the screen. And then the model takes this observation and chooses its next action. The whole interaction revolves around two core lines of code. Taking a step in the environment, which takes in an action and provides back how the game reacts, and the model taking the observation and deciding the next action, which is the prediction step. On the environment side, we are using the Stellar emulator, which allows you to play Atari games on your computer. On top of Stellar, we are using ALPy, which allows you to interact with Stellar within Python. And on top of ALPy, we're using OpenAI's Gym, which provides a nice reinforcement learning API, and that allows us to get away with as little coding as necessary to let model and environment interact. Stable Baselines3 provides us with a model as well as some utilities that allow us to train our model more efficiently, like callbacks and wrappers. Wrappers modify the environment in various ways. We will use the vectorized environments to have our model train on many instances of the game at the same time, and we will use wrappers to modify the resolution and the color space of the observations. And with callbacks, we can execute custom codes at specific events during training, and we can use them to monitor the progress of the training via evaluation environments. You can find all of the code on my GitHub page, which I will link in the video description. In order to run these codes yourself, make sure you have a look at the setup page. I made separate folders for each video, and this first one is called 1_gym. And now let's dive into the code. So here I've loaded up the most basic example I could think of. First, we import the OpenAI Gym. We create a new environment. We tell it we want to play Breakout. We tell it we want to have it rendered to a human user to pop up as a new window. And then we go into a for loop in which we define an action. So at the moment, I'm just taking a sample out of the action space. It just does stuff randomly. It does not decide. In a future version, we will put our model in here. And we take this action, we put it into an environment step, and we get back a bunch of variables, most importantly the observation. So let's have a look how that observation looks like. So you already saw the new window popping up for a second there. Let's have a look at the observations, first at the shape. So you see it's 210 pixels by 160 and it has 3 colors. And when we print it, let's actually use the spider functionality to show us. Sorry. Here it is. Let's go axis 3. And let's resize. And what you see here is this is the array that basically has the picture. You see the 0, that's the current score. And let's resize again. You see all the 142s. So that's very like the blocks. And when we scroll down a bit further, we will find the ball. And we will find the pedal. So the whole observation is encoded as an image. We also get a reward function I'm printing that out here. So currently the reward is 0 and the done is false, meaning we haven't hit anything, and but we're not done yet. And once we're done, we're getting out of that loop. We have lost the game, or well, maybe won the game, and then we stop the environment. So now let's watch the computer play the game. And you see with each step I'm taking in the debugger, the picture moves on one frame. And you see the pedal is doing nothing sensible, just randomly moving around, and it lost the game. So now this is where we would expect to see a done equals true, because, well, we lost. But what actually happens is that it just starts a new game. So you will now see the 5 went to a 4, meaning we lost a life, and, well, game goes on. In order to make the environment behave as we expect, we are going to put it into a wrapper. And for that, we're going to take the Stable Baselines Atari wrapper, Episodic Life, and we're just going to put the environment inside of that wrapper, and the rest is the same. So let's run this code. And we see it plays until a life is lost, and now the code stops. Let's see what happened. The last done equals true. Well, and if done, then stop the for loop. So now it behaves as expected, and we use the wrapper for that. We see it's not performing well, it just takes steps randomly, so that's to be expected. So our next step will be in training a model to play the game properly. The main piece of new code is this section here. We import from Stable Baselines the PPO model. We define it, we basically tell it which policy to take. We could provide it with some more hyperparameters here, we will come to that later. We tell it where to log, and then we tell it to learn. We define the number of time steps that it should take. This will take something like 15 to 20 minutes on my machine. And after that, it's more or less the same code. The main difference being in line 35, where we, instead of taking a random sample of the action space, we tell it to take a prediction from the model based on the observation space. So let's run it. In the console, you see it adds some wrappers. We will go into that a bit later, what they mean. And then we start seeing the different metrics which it is logging. We see the length of the game on average. We see the average reward. So we see something like every 4th game it actually hits 1 block. And we see some other performance metrics like the frames per second, how long it actually took to train up until now, and some other pieces. We can look at them during training in TensorBoard. So let's reset that. We see here the 1.3_train, and we see the average reward is slowly rising. I'll be back with you in a second. The last reward that we get per game is 1.26. So on average per game it achieves to hit 1 brick, which is not great, but we have a model that is not optimized in any way. We haven't added any hyperparameter tuning. We haven't even made a conscious choice for which model to take or which policy to take. So, well, let's be happy that it runs. We have created an environment that provides observations to our model. And our model interacts with that environment by taking actions. It's already doing slightly better than taking random steps, and in the next video we invest more training time, we use callbacks, and we vectorize our environment, making our model play many instances at the same time. Thank you for watching and have a great day.